All right, so we are now doing part 3 of 8-4, which is integer in the coordinate plane. So please have out your notes as we go through this.
A transformation of a figure is a change in its position, shape, or size. The new figure is the image of the original figure. A reflection is a type of transformation that flips a figure across a line called the line of reflection. A line of reflection acts like a mirror.
Okay, so let's go ahead and learn about the reflection across the x-axis.
Reflecting across the x-axis makes a mirror copy of the original figure on the other side of the x-axis. The coordinates of the original figure are 1, 1. The coordinates of the image are 1, negative 1. The coordinates of the original figure are 2, 1. The coordinates of the image are 2, negative 1. The coordinates of the original figure are 2, 2.
So you're going to notice that this red line right here,
The coordinates of the image are 2, negative 2.
This red line right here is the x-axis. So I always like to pretend that when you're looking for this, a reflection would be kind of like if you laid a mirror right here on this red line. Okay, and if you have this shape right here, the mirror would show the same shape right over here on the other side of the mirror if you flipped it over. So again, you're going to see 1, negative 1 instead of 1, 1. 2, negative 2, 2, negative 1. So if I have something up here in my quadrant 1 and I'm flipping it over the x-axis, the numbers and the x, or the first number, will always stay the same. Okay, but the second number we're changing to a negative number. Now let's look about the y. What happens if we reflect across the y?
Reflecting across the y-axis makes a mirror copy of the original figure on the other side of the y-axis. The coordinates of the original figure are 1, 1. The coordinates of the image are negative 1, 1. The coordinates of the original figure are 2, 1. The coordinates of the image are negative 2, 1. The coordinates of the original figure are 2, 2. The coordinates of the image are negative 2, 2.
So when a point is reflected across the y-axis, which is this one going up and down, only the x-coordinate changes. So remember, x is that first number, y is the second. So if we had this image here, and if our mirror was here, they're going to flip it, take it, and plop it down. So you're going to notice instead of 2, 2, which are both positives, now when we reflect across the y, the first number, which is x, is negative, and the second number, which is our y, stays the same. Same here. They were both positive, but now you just change that first one to a negative. Okay, same here. Both positive, change it to a negative. Okay, so it says complete each statement. Blank is the reflection of the point 3, 2 across the x-axis. So I remember if I have, this handy dandy thing, I remember that my y will be the number changing. So 3 stays the same, but 2 becomes a negative 2. Is the reflection point 3, 2 across the y-axis? So it's going to change. The y-axis means that the first number changes. So I'm looking for a negative 3, positive 2. Is the reflection point negative 2, 3 across the x? So again, the second number will change. So it should be negative 2, negative 3. And is the reflection point negative 2, 3 across the y? Well, if I'm looking at the y-axis, I know the first number changes. So if it's already a negative, I know it'll be a positive 2 and then a 3.
I bet you look in the mirror every day and never thought too much about how one works. It's showing you your reflection, where everything is reversed. Don't believe me? Test it out. Stand facing the mirror and wave with your right hand. Your image will be waving with its left hand.
Go ahead and try this data on your own. They want to know what is the reflection of 3, 4 across the y-axis. Here are some of your answer choices. When you are done, go ahead and do 8 foreign digits.